discuss, right? So if you haven't watched the previous session recordings, I recommend you to watch the recordings. So it will be clear like what are we going to discuss. Okay, all the playlist and everything is available in the group itself. I have pinned everything, right? Now let me share my screen. I hope my screen is also visible, right? Great. Yes. Right. So let us start with this arrays, right? So before going to start with this arrays, we need to know one important thing over here. So let's say, 1 minute, let me, where is it? Yes. So there are 2 points which we know, okay? So which is one is compile time and another is runtime. Okay, so one is compile time and another is runtime. Now, can anyone tell me what do you mean by compile time and what do you mean by runtime? Any answers for this? What do you mean by compile time and what do you mean by runtime? Yeah, thank you, Prince. So, what do you mean by compile time and what do you mean by runtime? Runtime means when the code is running and you try to change. Okay. Okay. Basically, during this compile time, this is a time where your syntax checking is going to happen. Okay. And where your compiler is going to check for all this syntax and everything, right? So it is going to check whether you have declared all the ports or not, whether you have declared your correct syntax or not. So this and all is going to happen in your compile time. Okay. And coming to your runtime or run phase, you can say this is where actually your code is going to execute. Okay. Execution of your code. Okay. Whatever the logic you have written, right? So that particular logic will be executed in the runtime. Okay. So exactly, the phase where the source code is processed by a compiler. Exactly, to check the syntax errors. Compile time means the code execution time, and runtime is where the simulation. Exactly. So basically, the compiler is going to have the checking part and whether everything is written syntactically correct or not, and whether you have declared any wrong data type or not. Okay, or incompatible data type or not. This and all is going to happen in the compile time. For example, if I'm going to have a module which is A, B, C. Now, if I'm going to write down reg 3 down to 0, let's say some array, okay, and within an initial beginning block, initial array is equal to 4 tick binary 1011, okay, end module. Now, during the compile time, my my compiler is going to check what is the size of the array that we have declared. Okay, whether it is 4 bits or whether it is 5 bits, it is going to check. Okay, so checking of the size and everything, evaluation of the size. Okay, evaluation in this particular example, evaluation of the size and whether it is syntactically correct or not. Everything is going to happen during the compile time. Okay, now, during the runtime, what is going to happen is this execution is going to happen during the runtime. Okay. So whatever the code which we have written inside our initial beginning block, that is going to be executed during the runtime. Is it clear? The difference between your compile time and runtime? So that we will discuss what do you mean by elaboration and that and all. But what is my agenda is to discuss this too because we are going to discuss them in our arrays concepts, right? Yeah. Is it clear for everyone? You can watch the synthesis part where we are going to discuss about elaboration phase and all that particular things we will discuss there. Okay. Yes. Now, so can anyone tell me where we have declared the size of the array, whether during the compile time or the during the runtime? In this particular example, I have declared a array. Now, where we have declared the array size during the compile time or during the runtime? Exactly. Yes. So during the compile time, I have declared the size of the array, right? And now, so please remember this. We will come back to this particular discussion again. Now, coming to my array concept, let me show you why I have discussed this particular things. So coming to my arrays in system Verilog, I have two type of arrays. Okay. So one is fixed arrays and another is dynamic sized arrays. Okay. So first let us try to have the discussion about our fixed arrays. Okay. Now coming to our fixed arrays, again these fixed arrays are classified into two types. Okay. So these are classified into packed arrays and unpacked arrays. Okay, so we have two type of arrays which we are going to discuss. One is packed arrays and unpacked arrays. Now, this fixed arrays are the arrays where your size is fixed during the compile time. You are not allowed to change the size during the runtime. Okay. Once in the compile time, when you have declared the size of that particular fixed array, that's it. You cannot change the size of that particular array during the runtime. Okay. For example, let us discuss about this packed array in more detail. So let's say, first of all, let us see the syntax of this packed array. If we are going to have a simple packed array, and this packed array is also classified into different types. We have 1D packed array, 2D packed array, and 3D packed array. We will discuss first about 1D packed array. Okay. So first we are discussing about fixed arrays. In the fixed arrays, we are starting our discussion about packed arrays. And in the packed arrays, we are going to start our discussion about 1D packed arrays. Okay. So coming to our 1D packed array. Okay. So this 1D packed array is similar to your vector. Okay. Which we have discussed in our Verilog. This is similar to your Verilog. Vector in Verilog. Okay. Now this is a fixed array. What do you mean by fixed array? The size is fixed during the compile time and you cannot change the size during the runtime. Okay. And coming to my syntax of my fixed array, how to declare your fixed array is first of all data type you need to mention. Next you need to mention the size. How to mention the size? MSB down to LSB, or else you can also mention LSB to MSB. Depending upon the NDNS, you can mention. Okay. Now MSB down to LSB or LSB down to LSB to MSB and followed by variable name. Okay. So this is how you are going to declare your array. Okay. That is nothing but my 1D packed array, or it is also similar to your vector in your Verilog. Okay. For example, how to declare it? Simply we are going to declare it as reg 1 down to 0 ARR. Okay. So how it is going to look like if we are going to declare a reg 1 down to 0 ARR. So it is going to look like this. So we are going to have two bits. This is 1 and this is 0. Okay. So this is nothing but my ARR. Okay. Which is similar to your vector where this 1 is my MSB and 0 is my LSB. Okay. And let's say if I'm going to simply write down reg 3 down to 0 ARR, which means I'm going to have three bits packed together. One, two, three. Where four bits packed together. Where three is my MSB, two is my LSB, 1, 0. Okay. So this is how your packed array is going to look like. Now, if I'm going to declare a packed array, let's say if I'm going to declare a simple packed array within a module, if I'm going to declare a simple packed array within a module like reg 1 down to 0 ARR. That's it. This size is fixed. You cannot change it dynamically during the runtime. Okay. So during the compile time, the compiler is going to decide, okay, you have declared it as size 2. That's it. Okay. So let's say within an initial beginning block or your always block, if you are going to assign the value, how you are going to assign the value? ARR is equal to 2 tick binary 1 0. Okay. You cannot increase the size dynamically. Let's say suppose if you are going to write down ARR is equal to 4 tick binary 1010. First of all, tell me whether this code is going to work or not. If you are going to write down simply ARR is equal to 4 tick binary 1010, whether this code is going to work or not, I want responses from everyone. Try to give the answer. If I'm going to write down ARR is equal to 4 tick binary 1010, is this code going to work? Okay, what may be the reason why it is not going to work if we are going to write down ARR is equal to 4 tick binary 1010? What may be the reason? Is it going to work or is it not going to work? If it is not going to work, what is the reason? Okay. First of all, this code is going to work. Okay. Now, okay, it is going to work. Now, if it is going to work, then what will be the value of this ARR? If we display this, what will be the value of this ARR? Is it going to be 1010? Exactly. Last two bits will be truncated, right? So this last two bits will be truncated. Okay. So the last two bits will be truncated and this will be stored inside this ARR. Here ARR size is not going to increase. Please remember this ARR will be 2 bits only because it is a fixed array and during the compile time the size is fixed. It cannot be changed. Okay, this is 0 and this is 1 and only the last 2 bits are going to be stored over here. That's it. Okay. So this is how your fixed array is going to work and this is especially your 1D fixed array. Okay. Is it clear for everyone? Okay, great. Now, let's say if I want to, let's say if I want to simply store a data into this 1D fixed array. Okay, so how to store the data into a 1D fixed array? Let us see. What happened to this? Yeah. So let's say if I want to store a data into this 1D fixed array. So let's declare a 1D fixed array, reg 4 down to 0 e. Okay. Now, if I display the value of a, what is that I'm going to get? Can anyone tell me? If I'm going to declare the display the value of a, what is that I'm going to get? Exactly. Why I'm going to get like that? Because reg, the default value of your reg is equal to unknown, right? Now, let's say if I'm going to simply write down reg 4 down to 0 a. Okay. So this is my fixed array, which is going to have 5 number of locations like this. 1, 2, 3, 4, 5. Okay. And this is my a. Okay. 0, 1, 2, 3, 4. Now let's say if I want to store a is equal to sorry, 5 tick binary 10110. Okay. 10110 12345. Yeah. Now what is going to happen? We are going to store 01101. Now let's say if I want to store at the MSB the data 0. So what I'm going to write down, a of 4 is equal to 1 tick binary 1. Then only the data 1 will be stored. Or if I am going to write down 0, then the data 0 will be replaced by this one. Okay. Let's say if I want to store the data 3 tick binary 111 in the locations 3 to 1. So what I'm going to write down, a of 3 down to 1 is equal to this is 3 bit, right? 3 tick binary 100. Then what is going to happen? This will be replaced by 100. Okay. So you can basically select which part of data or which part of the vector should be filled with which part of the data. Okay. So this particular is known as vector slicing. Okay. That is possible using this particular 1D packed array. Okay. Now let's say if you are going to have a is equal to 4 tick binary 1010, the same vector I'm going to take. And if I want to display, I can simply write down the display statement $display. The value of is some percentage d comma a. Okay, just that's it. So it is going to display the value of a. Sir, why you are teaching all this? You have already completed this in Verilog. Why again completing this? I will discuss. Okay. So this is very important because generally what happens is when we go into unpacked array, that generally people will get confused between unpacked and packed arrays. Okay. So that is the reason I'm brushing up all these particular things. Every time is taken only LSB, either we define reg 1 down to 0A or reg 0 to 1A, or it depends upon NDNS to take L. It depends upon the NDNS. If you're going to take reg 0 to 1, then 0 is nothing but MSB and 1 is nothing but LSB. Okay, it depends upon the NDNS you're going to consider. Okay, yes. So is it clear for everyone? I hope this is a simple concept. This we already know and we have already seen in our Verilog also, right? Shall we move forward? Yes. Now, coming to next type of arrays, which is our 2D packed arrays. Okay. So let us see how your 2D packed arrays are going to look like, and these are new to your Verilog, system Verilog. These are not present in your Verilog, right? Now, how to declare your 2D packed arrays? If I'm going to take a simple 2D packed array, let us see the syntax first. I'm going to have a data type followed by the size MSB down to LSB, and this is first dimension followed by second dimension. Okay, and the variable name. So this is a syntax which I'm going to follow for declaring a 2D packed array. Okay. So for example, if I'm going to take a bit 1 down to 0, 2 down to 0, ARR. Okay. Let us see how it is going to look like. Okay. So let's say if I'm going to have a 2D packed array, this is going to have basically two sections. Okay. So this will be my array where it is divided into two sections like this, where this is 0 and this is 1. The index for this whole section will be 0 and the index for this whole section is 1. Okay, so this is first dimension. And second dimension basically tells you how many bits are there in each section. So in this first section, we are going to have 3 bits, 1, 2 and 3. Okay, 1, 2 and 3. Okay, so this is the second dimension basically tells you in each section how many bits are going to we are going to have. This is nothing but my first section. Okay, and the inner one and the next dimension basically tells you how many bits are there in each particular section. Okay, so this is how your 2D packed array is going to look like. Let's see an example. Let's say if I'm going to have simply bit 2 down to 0, 3 down to 0, ARR, like this if I'm going to have. Okay, first let us see the diagram for this. Let's say if I'm going to have one, two, three sections, and in each section I'm going to have four bits. One, two, three, four. One, two, three, four bits. One, two, three, four. And the index of this section is 0, 1, 2. Now coming to this bits, the index of this bit is 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Okay. Now if I'm going to write down ARR is equal to how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 tick binary 1111 underscore 0 triple one underscore 1010. So what is going to happen is the bits will be filled in this particular order. Let me show you what is the order in which they are going to fill. So 0 will be filled over here, 0, 1, 0, 1, 1, 1, 1, 0, and all four ones will be filled over here. Okay, so this is how you are going to assign a particular value to this 2D packed array. Okay, so you can directly assign the value to this 2D packed array. ARR is equal to 12 tick binary 4 ones, and the 12 bit value you can assign. For example, if you are going to write down, let us take one variable as bit 3 down to 0 out, like this. If I am going to take out is equal to ARR of 2. Now can anyone tell me the value of ARR, sorry, out? If I display the value of out, what will be the value that is going to be displayed? What will be my out value that is going to be displayed? I'm waiting for your responses. Just give it a try. What is the value of out that is going to be displayed? Okay. So if I'm going to refer to ARR of 2, then this whole section will be assigned. Okay. So if I'm just simply writing down ARR of 2, I'm referring to this whole section, and this whole section is containing 4 bits. So out will be assigned to this 4 bits. So my out value will be equal to 1111. This is the value of out that I'm going to have. Is it clear, guys? Yes or no? So if I'm going to refer this first dimension, if I'm only mentioning the first dimension, then I'm referring to all this group bits. That is nothing but I'm referring to all these 4 bits. Is it clear? Yes. Now let's say if I'm going to declare one more variable as, if I'm going to declare one more variable as bit a, and if I'm going to write down a is equal to ARR of 2, and if I'm going to also mention the next dimension 3. Now what will be the value of A? If I'm mentioning ARR of 2, 3. Now tell me, I'm writing ARR of 2, 3. What will be the value of my A? I'm writing ARR of 2, 3. Now what will be the value of my A? Exactly, 1. Exactly, correct. So I'm referring to the last section, and in this particular section I'm referring to exactly the MSB. Okay. So the value of A will be equal to 1. Okay. Now let's say if I'm going to write down uh, out is equal to ARR of 0. Then what is that I'm going to have? If I'm going to write down out is equal to ARR of 0, then what is that I'm going to have? Exactly 101. I hope now you have got a clear idea about what I'm speaking about, right? Is it clear for everyone? Okay, that's great. That's great. Now, so that was about your 2D pack, that is simple. So 2D pack, that is, it is going to have 2 dimensions, and the syntax is data type, and the dimensions, the 2 dimensions, and the variable name. So, and the example we have seen. So this particular dimension is saying you or describing what are the sections we are going to have, and the next dimension is saying you like what are the bits which are present in each section. Okay. Now here you can simply declare a particular 2D packed array, and you can directly assign the value to this 2D packed array. Okay. You can directly write down ARR is equal to 12 tick by 12 tick value. Okay, it's allowed. Okay. And yeah, this was about your, and you can also fetch the data out of this 2D packed array by mentioning the section or by referring to entirely exactly that particular bit. Okay. Yes. So this was about your 2D packed arrays. Now coming to the last final one, which is nothing but our 3D packed arrays. Now coming to our 3D packed arrays, the syntax is data type, and first dimension MSB down to LSB, second dimension MSB down to LSB, and the third dimension MSB down to LSB. Okay, and followed by variable name. This is my 3D packed array. So how it is going to look like, let's see. If I'm going to take bit 1 down to 0, 2 down to 0, 3 down to 0. Okay. So we need to resolve it from the left hand side. So how to resolve it? So 1 down to 0, basically it is referring to 2 sections like this. So this is 0 and this is 1. And in each section, we are going to have 3 groups. So this is 1, 2, 3 groups. And in this section, we are going to have 3 groups. And in each group, we are going to have 4 bits. So this is 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 bits of data. Okay. So this is how your 3D packed array is going to look like. And the index is again 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, so on. Okay. So this is how your 3D packed array is going to look like. Now, how many bits of data can we store in this 3D packed array? Okay, what is your question? If we want to write down in 2D packed array, if we need to write in each section different length bits, where exactly? Can you give an example? Okay. Before that, tell me this particular exam. Tell me this one. So, what is the total number of bits you can store in this? Yes, yes, we will come to that application also. In two, we need to write 5 bits. No, we cannot have that like that. Okay, ChatGPT. Yeah. Yes, 24 bits. Exactly. Okay. So is it clear for everyone? Yes. Yes. Now, so let's see what is this application of this particular packed array, like where can we use? Okay, so this was your 3D packed array. Simple. If you are going to write like this, you can just simply have this partitions. For example, if you're having this A is equal to 24 tick B 1011, and the 24-bit value you can provide it. Okay, is it clear? Yes. Now, coming to let's say if I'm going to have a simple array like this, let's say if I'm going to have, let's say 12-bit range, 11 down to 0, A is equal to 12 tick binary, 1111. Let's say if I'm going to have like this. Okay. So it will be a array, packed array of 12-bit width, right? 1, 2, 3, 4, 5, 6, 7, so on, 12 bits. Okay. Now, let's say if I want to have first 6 bits of data, what should I do? Can anyone tell me? If I want to have the data of first 6 bits from MSB to first 6 bits, how to get it? Out is equal to what should I write down so that I can get that particular data? Can anyone tell me the syntax? Yes, exactly. I need to slice it, right? So 11 down to 6. Okay, I need to slice it like this. Now, instead of declaring like this, I can also write it as rich. If I make two partitions, 1 down to 0, and in each partition, if I'm going to have 6 bits, that is 5 down to 0. A. Okay. Now, I can simply write out is equal to A of 1. Yes or no? Is it also correct or not? Yes or no? If I want to get 6 bits of data. Can you able to understand now? Can you able to see here? Yes or no? Someone has asked, right? Yes, exactly. Okay. So basically you can have it for grouping. So you can see the difference over here. Yes. So this was nothing but your 1D packed array, 2D packed array, and 3D packed arrays. Okay. And storing and displaying all will be the same thing, just like displaying your vectors and things, right? Yes. So this was about your packed arrays, and next we are going to discuss about our unpacked arrays, and we will differentiate what is your unpacked and packed arrays so that you will get more clarity. Yes? Okay. So if you have any other doubts or any other queries you wanted to discuss with me, you can have the discussion, or else you can leave the session. Okay.